So the problem we're tackling right now is the longest valid parenthesis. This is number 32 on LeetCode and it's considered a hard problem. And we're going to be given a string containing just open parenthesis and closing parenthesis characters, and we're asked to return the length of the longest valid well-formed parenthesis substring. So when you're working with checking to see if a string is valid when it comes to parentheses, open and closing, it's usually a good idea to throw a stack at it. And the reason why is a stack will keep track of the most recent open parentheses you have and allow you to match up these open parentheses with closing parentheses. So if you've ever seen the problem like given a string, determine if it's valid, that's probably the approach you're going to take. But in our case, we need to keep track of the longest valid substring that we have found at any given time. So let's take a look at two examples that'll help illuminate a solution for us. If I have a stack here and then I have just this example right here, I have index 0 and 1, right? So if I just naively put 0 onto the stack and then just pop it off of the stack when I find a corresponding closing parentheses and just subtract their indices, I'd have 1 minus 0, right? Which is equal to 1. And my length is 2. That's not quite correct, right? So let's think about possibly a better way to initialize our stack. If I initialize my stack with a -1, then this handles this corner case right here, right? I can put 0 onto my stack, and then when I hit the 1 here, I would pop from my stack, and then I would subtract the most recent element that is on my stack. And that would give me the span, so to speak, of the valid parenthesis substring. So I'd have 1 minus 1 equal to 2. But this isn't the only reason why I might want to initialize with a -1, right? Let's take a look at a more difficult example, which is this one here. If I initialize my stack with a -1, what I can do is allow myself to pop from the stack whenever I find a closing bracket without necessarily needing to just check if the stack actually exists. So I can just pop it immediately. Then, since nothing is on my stack at this point, I'm going to put the index of my closing bracket on. And this guarantees that I will at least have one element on my stack that I can then use as sort of the left pointer, and then I'll have a right pointer later to allow me to calculate the distance between them, which will give me a valid parenthesis length. I put 0 on. Now I'm at 1. I cancel the 0 out. And now I have nothing on my stack, so I'm going to put the index of my current closing parenthesis. Now, keep in mind, if I have nothing on my stack and I have a closing parenthesis, there is no point in me checking to see if a valid substring exists before this, because we know the only element I have is a closing parenthesis. Now I have an open bracket at 2. Well, an open bracket is 2, so I'm going to put that onto the stack, and I'm not going to check the length, see if there's a valid parenthesis, because I know I am ending with an open bracket. So there's no point. I'm going to go to 3 here, put 3 onto the stack the same way I did with the open parenthesis here as well. And now I come to 4. 4 is a closing parenthesis. So I'm going to pop from my stack, and my stack is not empty now. So I'm not going to put a new element onto my stack because I have a corresponding open bracket for it, right? That was 3. What I can do is take the index of my closing bracket and then subtract the current index I'm staring at on my stack. And this will allow me to get the current length of the substring that I'm staring at that's valid. This is equal to 2. And this is correct because I'm stopping at this point. So the only valid parenthesis substring I have is these 2 brackets right here. Now I'm going to go on to 5. 5, exact same thing we did before. I'm going to pop the most recent element on my stack. And then since I still have an element on my stack, I am not going to just add the index of my closing bracket here. Instead, I'm going to subtract. So I'll have 5 minus 1, which is equal to 4, right? And that's correct. This little box right here is my current valid substring, and it is length of 4. Now I go to 6. 6 gets put onto my stack, and then I go to 7. 7, closing bracket. So again, I pop what is on my stack, and now I do 7 minus 1, which is equal to 6. And this is correct because this entire thing right here is valid. We have open and closing parentheses that are matched, and then we have open and closing parentheses that are matched. So the maximum valid substring that we would have is 6. And this algorithm right here would just be what? Big O of n, I have to touch every element on my stack. It's perfectly fine. So now let's go over and code it. First thing I'm going to do is initialize my result that I'm going to keep updating. Then I'm going to initialize my stack. And we're going to be doing that trick I talked about, which is going to handle our sort of edge case at the very beginning. And we're going to put -1 on. Now, for I char and enumerate s, I'm going to go through every character in my string exactly once. And the first thing I'm going to do is check and see if they're open. If char open parentheses, what am I going to do? Well, I'm just going to append my index, right? Okay. Now, since I know that there are only parentheses in the open and closing, I don't need to check and see if there's any other characters. So that means if we're not open, we're closed. So I can just put an else here. First thing I'm going to do is pop from the stack. Stack.pop. And remember, we are guaranteed to have an element on the stack, so this is a safe option to do. Stack.pop. Now, if not stack, so if we've popped everything off of it, then that means that we just have a closing parenthesis, so there's no point in checking if there is a valid parenthesis before this. And I'm just going to put onto my stack the current index we have. Stack.append I, just like I talked about. And now I'm going to type continue. And the reason why is because I don't want to check, see if there's a valid parenthesis. We know there isn't. So result is equal to max of result, and then I minus stack, basically the top of it. So this case right here is going to happen if we still have elements onto our stack that are open parentheses. And this will give me a sort of an update as I move along my string to see if there is a longer valid parenthesis substring. Now all that's left to do is just return it. Okay, so let's do a quick check. This looks good. Let's try running it. Passed all the cases. Let's submit. And we have solved the problem. Thank you.